Hello, everybody. My name is Alexander Döring. Like I said before, I work at smallpdf.com. This is a startup here in Zurich. And I want to tell you how you can run Go code in your browser. Might sound a little bit strange in the beginning. Hopefully, it doesn't sound so strange after my talk. We will see. In general, I will cover two different ideas. Go4JS, which works right now, and which I will go a little bit more in detail with examples. And WebAssembly, which is lies a little bit in the future, but hopefully in the near future. So what is Go4JS? The basic idea is pretty simple. You transpile your Go source code to JavaScript. And this JavaScript you can then run in your browser as much as you want to. It has almost 100% support of the standard library. There are some small exceptions, but most of the time, most of your libraries will just work. You can just compile them to JavaScript and they will run. Go can interact with the DOM. JavaScript can call Go code, and Go code can call JavaScript. So you have interoperability. So this sounds pretty nice. It was started by Richard Musial, Nylance on GitHub, and we will come to him later a little bit. But of course, it's an open source project. Everybody can contribute, and a lot of people have. So how would you do that? Basically, instead of Go build your Go code, you can Go4JS build your Go code. Then you just transpile it. The output is a JavaScript file. You can also serve your code locally. So this is especially nice for developing. It's even with hot reloading, just with Go4JS serve. Let's maybe start with a really simple example. I have here an HTML page with a button, a display, and JavaScript source. This example 1.js will be the transpiled output of my Go program. And I will run it like this in the browser. Let's look at some very simple Go code. We will use a library to interact with the DOM. We will get the document. We will get the click me and display by getElementById. But already we have a somewhat interesting thing here. We cast it to a type. This means you can write front-end code with type safety in mind, with types. Then to the button, we add a simple event listener. And if we click this, we display hello world. The interesting part is because we transpile the code to JavaScript, and it's an HTML page. And the Go present tool, what I'm showing you right now, is HTML. This means I can, basically, I have included the example1.html as an iframe in this presentation, and I can show you the code live. So we have the button here. Click me button. We can click it and we see hello world. Okay, but this is very simple and maybe a little bit boring. Let's do something more interesting. For the second example, keep everything the same, but change the code in the event listener. Instead of just setting some text, let's actually spin up some Go routines. Yeah, you heard me right. We are going to run Go routines in JavaScript. So we spin up 5 coroutines. We sleep for a random amount up to 5 seconds in each coroutine. And then we get the text of the display, append our number, and set the text of the display. Let's ignore for now the slight data race in there. You might have noticed it. Before getting the text and setting the text, in theory, something could happen in between. But let's look at this simple example. Same as before, we have code in an iframe. I can hit click me again. We need to wait a random amount of time, and some random numbers appear. This time we can even do it again. Okay, this tells you a little bit already that really I was not lying when I said in the beginning that most of the standard library is included. Like literally like 99% of all tests work, and you can use all the nice things of Go you're used to. You can use Go routines, you can use channels, you get your type safety, everything just works. Yeah, I need to get out of that. Okay, the next question is, this is all very nice, but why the heck would you actually want to do something like this? Okay, it is a little bit crazy, but let me try to convince you. The first thing, I imagine most of the people like me are a little bit more back-end developers compared to front-end developers. So for me, if I would write a simple project and I don't want to write front-end for it in with React or Angular or something, maybe I can do something really quick with Go. I mentioned before that I get my nice type safety. But this is quite nice, but for me, not the main reason why you would want to do stuff like this. For me, the main reason is the second point. This means replace processing in the cloud with processing in the browser. This means instead of the user uploads a file, we do processing in the server and the user downloads a file, which takes some time and takes the company quite some costs for servers. Imagine a future if all of this processing can happen on the computer of the user. This means for the company, I don't pay for my server cost anymore. For the user means, depending on the file size, it might actually be faster because you don't need to upload and download a file. And for the user, this also means this is way better for my privacy because I don't need to send my data to the cloud to do something on this. The data, in the best case, never leaves my computer. And the really nice thing for me or for us as backend developers, all the pure Go libraries that you are using in your backend today, you can use in the front end. So if you have currently a processing library in Go that runs on your server, I bet you can just compile this library without any alterations at all and run this library in the browser. To do the front-end part, I mean, as front-end developer, I would say they love to use frameworks for everything. And there are a ton of frameworks and a ton of different frameworks. But Go4JS has you covered. There are bindings for Angular. There are multiple bindings for React. There are even other bindings for Vue or whatever is the current hip framework. There are even bindings for Electron, if you want to. And Go4JS itself also has a really small framework, a small React-like framework called Vecti. And I will give you a small example of how to use this as well. The HTML file of our next example got even simpler. We don't have any diffs anymore. We just include the JavaScript file. Same as before, this is the transpiled output of the Go file I am showing you later. We have a package main, we have some includes, and in the function main, all we do is we tell Vecti render HTML body. And the HTML body is a custom component that I have declared here. It's a page, is simply a struct. We embed Vecti core as one part to make it a component. And then I just declared a text string there. The Vecti core is the first part to make it work. But the other part is we need to tell Vecti how the hell should you render this type page. And we do that with a render function. The output of this is Vecti HTML. And I guess, at least for me, this has quite a React feel. Basically, you return a component. What we're returning here is a body. We can even style it in Vecti. So for example, here we set the font size to 20 points. Of course, for larger projects, you can also do your CSS in an extra file and then just use it like you're normally used to. This is no problem at all, but you can also do it with Vecti. Then we have an input element with markup. The markup is one event handler. I will come to that later. So we have an input element, a line break, and then text, a text element. And the text element, we basically print the content of our member variable text. So what we expect is an input field and a text field that we use as output field. Let's look at the event listener now a little bit more. We get the text of the input field, and then we double this text with an empty space in between. But this means we only store the text in the private member variable. We don't do anything yet with it. And the magic happens later. Vecti re-render, we tell Vecti to re-render the page. And Vecti actually, similar to React, uses a virtual DOM. So it is smart enough to only re-render those parts of the page that have actually changed. And the parts that will actually change then is, of course, the text in the display. Same as before. I have the HTML included in the iframe. Let's write some text. So you have can write quite some interactive stuff. So those were some simple examples. I have not tried the bindings for React or Angular myself, but if you are more front-end developer and are used to those frameworks, Gopher.js also has you covered. One interesting thing about Gopher.js, size matters. On the server, we don't care if a Go binary is 1 megabyte or 5 megabyte or 20 megabyte. But if your user has to download this JavaScript, it matters quite a bit. So there's a couple of things you should do and a couple of things you shouldn't do to help you in this regard a little bit. The first thing, for production, you should always minify your build, similar like you do in the front end as well. This is Very easy with Gopher.js. It's just Gopher.js build -m. Then, of course, you should also gzip this. But depending on what you're using, I mean, this is basically automatically. We are talking about here about a site without a server. So this is a static HTML and static JavaScript that you can put on AWS S3. You put CloudFront in front of it, and this will automatically gzip your resources. And you have an infinite scalable interactive website. You pay to Amazon, but you don't have to care about servers, and you can get rid of a lot of complexity. One very interesting thing is, even in the Go standard library, there are some packages that are larger than others. A particular pain point here is the FIMT package. This is way too large. So if you do a small project and include that, your code size can grow by 1 megabyte or something. So you shouldn't do that. There are multiple alternatives. Sometimes you can do things with strings or other functions, but there are also third-party FIMT packages that are written with size in mind. So you shouldn't use the FIMT package of the Go standard library. Another thing that you probably shouldn't use is NetHTTP. Especially, we are running our code in the browser, so we don't care about all the server parts of the HTTP package. So this is just a lot of unnecessary code. And most of the time, we are only caring about our AJAX requests, and we can do this with a different package. But other than that, you have seen now, this is actually stuff that works right now. You can actually already do that. I have written a fourth example that's a little bit more complex. I've even put it on a domain, resizerly.com. Basically, it's a site that resizes images in your browser, and without uploading it to the cloud and everything. And yeah, it is, like I said before, it's a static site on S3 with CloudFront in front. So let's take a look at this. I've run a local code. Basically, I've a static website, and it says drag and drop an image. So let's drag and drop a Gopher on there. Well, so you can see I can interact with the JavaScript functions. Now I have a Gopher in there. I can resize the thing. Notice that the size of the image dynamically updates. Let's make this Gopher a little bit larger. Let's make it 200%. And then I have an almost fake button, resize and download. The download actually doesn't happen, but explain this to your user, I don't know. So let's click on here. And now I have a resized Gopher here, a way larger Gopher. So you can see this actually works. For this particular example, the minified but unzipped JavaScript is a little bit over 1 megabyte. And gzip one is a little bit under a megabyte. Of course, this is on the higher side, that I would like that, that this would be smaller. But instead of uploading an image, processing it, and downloading an image, this might still be faster. And to be fair, some or most websites, 1 megabyte isn't even that much today. Okay, so this is the technology that works today. let's talk about the technology that also works today, but doesn't work with Go today. And this technology is WebAssembly. It's a low-level bytecode and stack machine run in your browser. It's influenced, and I would even say it's the successor of ASM.js and Google's portable native client. It's supported by all major browsers. Safari was the last one in this summer. So this is really independent platform independent and browser independent code. And this is really bytecode that runs in your browser. And by default, it's since inception, it was always a compilation target for C and C++. So you write your C++ code and compile it to WebAssembly. As a side note, Rust announced preliminary support for this, I think, last week. So the race is on, so to speak. Because honestly, I think this has huge potential in the future. Imagine what I told you about what you can do with Gopher.js already. And now imagine you wouldn't need to parse a huge JavaScript file in doing that. So WebAssembly might be a huge improvement over that. One part that is a little bit lacking yet is the interacting with DOM. So currently, it would be like you write a function that you compile to WebAssembly, and you export this function, and you have your separate JavaScript code that imports this. But honestly, this would even be the same way of how I would write a larger project with Gopher.js. You write the Go code that does the processing, you export a single function, and then you can write your front-end code with React or Angular, with Webpack, with all the tools the front-end developers are used to, and then you import the single function. So let's talk a little bit about Go and WebAssembly. So we have this issue 18892. This was opened in February this year. Hey guys, WebAssembly is a thing. Maybe Go should have something to do with that. As you can see from the thumbs up, everybody liked the idea, but it turned out pretty quickly like we have no idea how to implement that yet or implement that immediately. And after a little bit of discussion, after a couple of weeks, the sentiment was even, is this even possible? Or would WebAssembly need to change that Go can use this as a compile target? Because WebAssembly is a little bit different than other things, but I don't want to go too much in detail. This issue then lingered around for quite some while, but 3 days ago, so this is really, I intended to give my talk mainly about Gopher.js and then only drop 2 sentences about WebAssembly, but literally 3 days ago, Nilens, you might remember this guy. This is the creator of Gopher.js. He said he has started working on this, building this, and he is very optimistic, I would say. He worked on it in over a month and a half, only in his spare time, and he even says this might land in Go 1.11. So what I said before, this might be the future of how you could run code in the browser. That actually might be the near future that happens maybe next year. So Nilens has a fork of Go on GitHub. You can contribute. You can look what the current process is. Currently working already is running the generated code in browsers and in Node.js if you want to do this particular hurtful way. I don't know if you would want to. You have Go code, you compile it to bytecode to run it with Node.js on your server. But if you want to, you could. Basic operations already work, conversions, etc. Interfaces already work, and Go routines and channels already work. Stuff that doesn't work already, reflections, growing the stack of Go routines, garbage collection is an issue. And of course, there are a lot of optimizations to do and probably a lot of other small things. So, but let's recap a little bit. To run Go code in your browser, of course, it's early days still, I would admit that, but I really see huge potential for some applications for this in the future. Go4.js is working right now. WebAssembly is going to work soonish, maybe / probably already next year. So I've given you the link here. So experiment with it, contribute to it if you want to. It's open source. And I will give you the slides and a meetup comment. And I also have prepared a slide for hiring. So like I said before, Small PDF is hiring. This is only a side project, so we don't use that at work. But I'm somewhat hopeful. If you're interested in joining Small PDF, maybe you can even work on something similar in the near future, because for us, this would be quite nice. So thank you for your attention. Any questions?
Can you give an example with channels running in the browser?
Yeah.
How does this concurrency map?
Basically, of course, a JavaScript doesn't run in parallel. So you still run only in one thread. And basically, but parallelism is something different than concurrency. So what happens is this one thread will schedule multiple Go channels one after another. And you have a similar thing as if you have way more Go routines than you have cores. There you can see this as a computer with only one single core. And then everything has to run one after the other.
How cooperative does that have to be? For example, if I launch a Go routine with an infinite loop in it?
Actually, this is a problem. And but Go has in the runtime Go schedule method where you can literally say, I'm running in this tight loop, but I want to give Go a chance to run something else. So, I mean, Go has or had some similar problems if you run really, really tight loops in the server, that even this could happen. But of course, with JavaScript and Go4.js, you have to be way more careful with that. Other questions? Okay, then talk to me later.